everyone, and welcome back. My name is Mr. Cobalt, and in this video, I'm going to be talking about detecting radioactivity. That's right, we're going to talk about how do you detect or what instruments you use to detect radioactivity. And so let's get into this. Particles are emitted by radioactive nuclei, and these particles are very energetic. So what we need to do is have a device that's going to take those particles in and detect those particles. So how are these particles detected? They're detected by going through and interacting with either atoms or molecules. So if they are interacting with atoms and molecules and causing those atoms or molecules to become energized in some way, then that can be detected. So the most common radiation detectors are what are called the thermoluminescent dosimeters. So these are like those little badges. You'll see these badges that are seen by people who are working in power plants, nuclear power plants, or who are working with nuclear material or are in occupations that are involve radiation. Then you'll see those badges, and they have those thermoluminescent dosimeters in the badge. And so these dosimeters, these thermoluminescent dosimeters, they contain crystals of salts. And these crystals of salts could be something like calcium fluoride salts. And then these crystals of salts are excited by ionizing radiation. So the particles come in, they ionize the crystals, and then the crystals become excited. So these excited electrons in the crystals are trapped by impurities, and these impurities are purposely put into the crystals for the purpose of trapping the excited electrons. Then, when the crystals are heated, right? So we got these excited electrons that are trapped. So when you go and you finish your job, you got to turn in your badge, and what they're going to do is they're going to then use some sort of process to heat it up, and then those electrons are then going to relax to their ground state, and that's going to emit light. And so what happens is that the amount of light that's emitted is proportional to the amount of radiation exposure. So the people who work in these areas are constantly and regularly putting in and turning in their badges, and those badges are checked to see how much radiation or how much exposure to radiation these individuals are getting. And so that's how this works. So that's your thermoluminescent dosimeters. We also have what are called Geiger-Muller counters, or what are also known as just Geiger counters. So how does a Geiger counter work, or a Geiger-Muller counter work? Well, again, these particles are going to pass through a substance. And so here the substance is argon. So there's an argon-filled chamber at the end of your Geiger counter. So you've probably seen a Geiger counter in a movie, if not in class. So it's got like a little thing that looks like a microphone that you sing into, but it's not a microphone you sing into. So that the end of that microphone looking part is the argon gas chamber. And in that chamber is also a wire, and it's a high voltage between the wire and the surrounding walls. Right. So when the particle goes through the argon-filled chamber, it's going to cause the argon atoms to be ionized. So now you've got positively charged argon atoms, you've got negative electrons, and this is a high voltage area. So what's going to happen? You're going to get a flow, you're going to get a current that's going to be produced slightly for a little bit of time. So electrons are going to be moving, the positive argons are going to be moving. That's going to cause a current to occur, and that current is going to be picked up and detected. And so that's going to be then converted into either a blip on a screen, or it's going to be converted into a noise. That clicking noise that you've been familiar with, if you've ever heard Geiger counters, especially on the movies, you hear that clicking noise. So that clicking noise is the ionization of the argon atoms being picked up by the detector in the Geiger counter itself. And then finally, we have what are called these scintillation counters. And how a scintillation counter works is that you have, again, radioactive emissions are going to pass through a material again. And so that material could either be sodium iodide or it can be cesium iodide. And so what's going to happen is that this substance here that the emission is going to pass through then emits UV or visible light in response to the excitation of the high energy photons. So the high energy photons go in. That's going to excite the electrons in the material. The electrons are then going to relax, and they're going to emit light, either UV light or visible light. That light again is then picked up by the detector itself, and then it's translated into some sort of response. So usually like an electrical blip on a screen or a moving needle, right? So the needle will move, or it could be a sound or an audible sound, just like with the Geiger counter. So that's how that works. So those are three ways in which we can detect radioactive decay or radiation being emitted from substances. So we have our thermoluminescent dosimeters, we have our Geiger-Muller counter, and we have our scintillation counter. So I hope this was helpful. I hope you learned a lot from this video. I hope it was interesting. If so, please, by all means, like the video, hit that like button, smash it. Also, subscribe to my channel, hit that notification bell somewhere up here. Maybe it's down here. They move it on me, and I'll have to double check to make sure I know where it is at. But I'm sure you can find it. Once you find it, hit that button. Also, once you hit that notification bell, make sure you hit all, so that way you can be notified by all the videos I put out. Finally, put a comment down there in the comment section below. Let me know what you think. Ask me questions. I'd love to hear from you. Thanks for joining me. Have a great day.